Hello everyone, my name is Nitesh Chandra, Computer Science and Engineering branch, BTech second year. Today in this video we are talking about hardware control unit. Hardware control unit is a very important topic of computer organization and architecture. Before starting hardware control unit, we first talk about what is control unit. Control unit is a part of central processing unit which is act as a brain of processor, all the operation which is executed inside the system, all this are controlled by control units. Like whenever the CPU execute an instruction, the control unit generate control signal the that tell different component like ALU, register, and memory what operation to perform. So it is act as a brain of processor and very important part of computer system. So there are mainly two type of control unit. First is hardware control unit. Uh, in hardware control unit, the control logic control logic is implemented using hardware circuit hardware circuit like logic gate, flip-flop, decoders, encoders, and other logical circuits. So this means the control signals are generated directly using digital hardware circuit, not using program. There is no program uh, which is used to send instructions and control signals. So instead of storing controls instruction in memory, the control signals are produced by physical hardware connections. First is instruction, decoder, logic circuit, control signals. So this is a definition of hardware control system and what is hardware control system. Now we talk about working of hardware control unit. Hardware control unit is mainly consist of instruction register, decoder, clock, flag, encoder block, and system bus. So the working of hardware control unit. Hardware control unit gets set of input from instruction register, flag, clock, system bus, and transform them into a set of signals. They send their inputs from here, and here in the form of I1, I2, I3, IN, T22 to TN, and it is transform them into the control signals. So instruction decoder decodes the instruction loaded in instruction register, like the instruction which is loaded inside the instruction register from the memory is decoded by instruction decoder and sent in the form of set of inputs like I1, I2, I3, IN, and the sequence counter provide a separate signal line for each step or time slot in the control sequence, like T1, T2, T3, like here. This is sequence counter. You can see that this is sequence counter. It provides the sig- single line like one, two, like TN for control sequence. After execution of each instruction, and signal is generated, which reset the control sequence counter. After execution of all this, and signals are generated, and which resets the control sequence counter and make it ready for generating the control sequence for next instruction. Let the process happen again and another new instruction is performed and new control signals are generated. So this is the working of hardware control unit. Hardware control unit is generally faster and simple in design, but they are less flexible and more difficult to modify or update. So here you see the advantage and disadvantage of control unit, hardware control unit. Um, the main advantage of hardware control unit is speed. It is very fast. Since control signals are generated using hardware circuit, execution is very fast. We use hardware circuit for generation of control signals, so execution is very fast. So because of this reason, this processor usually use hardware control unit. So this processor are implemented using hardware control unit. The main problem is lack of flexibility. Like disadvantage of hardware control unit is the instruction set and control logics are tied together by special circuit, which make the design complex and difficult to modify. Updation and modification is very unflexible. You can say that. If hardware computer is designed and later the instruction set need to be extended, need to be extended, the physical component of computer must be changed. Like physical component of computer must be changed for if instruction need to be extended. So this is a problem, disadvantage of hardwired control unit. This because this become very expensive because new chip must be fabricated and old must be removed. So this is advantage and disadvantage of control unit. And we head toward a new diagram of hardwired control unit of basic computer. So there is a two decoder, sequence counter, and logic gate make hardwired control unit. Like here you see that 3 cross 8 decoder, 4 cross 17 decoder, control logic gate, and 4-bit sequence counter. So the instruction register store an instruction retrieved from the memory unit. Like here you see that the instruction register store instruction and retrieve from the memory unit. Instruction is retrieved from memory unit and consist of operation code 12 to 14, then 1 bit and 0 bit through 11. The operation code bits are 12 to 14 are decoded with 3 cross 8 decoder and 8 decoded output go to control logic to perform specific operations like D0 to through D7. Like here you said it. D0 to D7 is when decoder decodes all these inputs, it's go to logic gate. The last bit, 815, is transferred to flip-flop designed by symbol I. Like here you see that last bit is transferred to flip-flop design designated by symbol I. The first 12 bits are applied to control logic gate and the fourth bit sequence counter and 4-bit sequence counter can be counted for 0 to 15 in binary. Its output is decoded into 16 timing pulse through 0 to through 15 with 15 cross 6 decoder. Like output is decoded by 15 times. The SC implemented by INR input or clear by CLR inputs simultaneously. So output is implemented by INR and clear by CLR. So execution repeat and repeat. So that is all hardware control units. We had to work to next topic. To overcome this disadvantage, another approach was developed called the microprogrammed control unit, which is another type of control unit other than hardwired control unit. In microprogram control unit, the control signals are generated using micro instruction stored in memory. The memory is called control memory. So a microprogram control unit is implemented using programming approach. Like it's used programming approach like executing small micro instructions for generation of control signals. In microprogrammed control unit, the control information is stored in control memory. The control memory is programmed to initiate the required sequence of operations, micro operations. So control the control information is stored in control memory and control memory is programmed to initiate the required sequence of micro operations. Like in control memory contains microprogram. A microprogram is sequence of micro instructions. Like a microprogram is a sequence of micro instructions which is held to generate control information. This micro instruction is basically the sequence of micro operations required to execute an instruction. So we had the word micro program control unit. The microprogram control unit is a control unit which the control signal are stored in binary form. Like a microprogram control unit is a control unit in which control signals or control informations are stored in binary form, like 1 and 0. as a control word in a room chip called control memory. So here you see that this is a control memory ROM, and this is a ROM chip, and inside ROM chip this is control words in the form of binary, and inside each chip there is some micro instruction which is used to generate micro operations. So each control word in control memory contain micro instructions. Like each control words in control memory contain micro instructions, and micro instructions specifies one of the or more operation for the system. So the micro instruction present inside control memory specify one or more micro operations for the system. A sequence of micro instruction is called microprogram. We heard this. Execution of micro instruction is responsible for generating a set of control signals. A control memory is assumed to be read-only memory, which all control information is permanently stored. Like control memory is assumed to be read-only where the all control information, like all control signals, is permanently stored. The address of micro instructions stored in control memory is generally by the micro sequence with the help of instruction registers. Like register helps to store micro instructions in the control memory. So the task of microprogram control unit, micro instruction sequencing, like determine the order in which micro instructions are executed. Like what is the order of micro instruction to be executed in the control memory, and micro instruction execution generates the required control signals for the CPU operation, like the operation which is executed inside the CPU. It's required control signal for the generations. So microsequencer, the microprogram sequencer generate the address of new microinstructions. So here you see the sequencer micros of microprogram generate the address of new instruction, like it generate new micro instruction for micro operations. It determines the next instruction based on the instruction stored in the instruction register. Like here is instruction register. Instruction register is a consist consist of instruction which is loaded from memory, and it is sent to sequencer starting and branch address generator. So instruction register, here is it, store instruction fetched from the memory and send instruction information to microsequencer. Here in this. And next address generator Microprogram sequencer determine the address of next micro instruction. Like it it determine next micro instruction. Use instruction register external inputs. For the generation of next micro information, this these things are responsible for the generation of new inputs. The control address register is a micro processing store address of next micro instruction. It's act like a microprocessor controller to be executed. Store the address of next micro, which is executed by sequencer, and so here it's sent to this, and new instruction is new instruction. New instruction. Send this address to control memory. Okay? Control memory, read-only memory, store all micro instruction. Each micro instruction store a control word, like we read above. Like control address register holds the address of next instruction, and send this address to control memory. And control memory store all instructions like here, and each is stored in control words like in the form of control words like binary 1 and 0, 0 form. And control data register CDR hold the micro instruction read for control memory, and decoder decode the control words which in the form of binary generate control signal for CPU component and system bus. Here it is. So this is the micro control unit components which are used for generation of control signal for CPU component and system bus. Working of microprogram control unit, the next generator called microprogrammer sequencer is determine the address of sequence of micro instruction and read from the control memory that are read from control memory. And the control address register hold the address of next micro instruction which is generated by microprogram sequencer, and it's sent to control memory. The control data registers hold the micro instruction read from the control memory, and the control memory contains a set of micro instructions, and micro instruction contains control words specify one or more micro operations through the control signals. When an address available in control register. The sequencer issue a read command, the receive it, read command to the control memory. After the read command, the word from the address location is read into the data register CDR. The con- content of CDR generate control signal and next address information. The working of CDR is the generation of control signals and next address information. The sequencer load new address into the control address register based on the next address information. So it is a working of micro-programmed control unit, which is which is implemented by programming approach. So the advantage of micro-program control units are the design of microprogram controlment is very simple, less complex because microprograms are implemented using routines. Like it's use softwares to implement the programs and instructions which is used to generate the control signals. It is cheaper and less error prone to implement. It is more flexible because design, modification, corrections, and enhancements can be done easily. It is very flexible for updation and modifications. A new modified instruction set of CPU can be easily implemented by rewriting or modifying the content of control memory. Like if we want to new or modify the instruction set of CPU, we just change and modify the program. There is no need of change of hardware circuits, sorry. Complex functions such as floating point arithmetic can be realized efficiently. CSF complex instruction set computer system are implemented using microprogrammed control unit. Like RISC is used for implementation of hardware circuits and this is complex instruction set computer system are implemented using microprogram computer systems. So that's all from my side. Thank you very much for your time. Thank you.